Hello, and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in sustainability, climate change, buildings, and urban efficiency. I'm Vic Marinich, Global Marketing Director for Danfoss, and I'm delighted to be the host of this podcast. You can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever you get your podcasts. Today, we have Beau Berthelot from Maritime Partners here to talk to us about his company's Hydrogen One tugboat and its use of methanol as a fuel source. Beau is Vice President of Business Development and Director of Government Affairs at Maritime Partners, a leading provider of maritime assets, vessel leasing solutions, and construction financing. Beau, thanks for taking the time to join the show.
Thank you for having me.
So to me, the whole hydrogen topic is super interesting. It's something we're reading a lot about, seeing a lot about. In the U.S., we just had, 7 hydrogen hubs announced here in the U.S., so it's definitely becoming a high priority. And you guys are kind of cutting edge and leading the way here. So can you maybe tell us a bit about the process you had for developing and launching Hydrogen One?
Yeah, absolutely. So Maritime Partners, as you mentioned, we're a vessel leasing company, and our fleet is made up of approximately 1,850 tugboats and barges. We are predominantly catered to the U.S. inland marine transportation market. So one of the missions that we established early on was how to provide a solution to our customer base, which is the inland pushboat barge operator, that would allow them to transition to something beyond traditional diesel propulsion. So Maritime Partners, actually before my time at Maritime Partners, they sat down, they surveyed what was currently available in the market application-wise in the marine industry, and identified a lot of challenges with a lot of different types of fuel, alternative fuel, and settled on the methanol-to-hydrogen generation technology. Maritime Partners joined in a joint venture with a company called Element One, which is the proprietary holder of the hydrogen generator technology, and another company called Ardmore Shipping. And together they formed a company called E1 Marine. E1 Marine holds the exclusive global license for the marine application of the methanol to hydrogen generator. And in a very broad perspective, this solution seemed to be the best fit based on what was currently available for the vast majority of our customer base.
Mm-hmm. What kind of challenges did you have sourcing the methanol and implementing this technology, right? How did you address those kinds of issues?
Well, honestly, that's one of the reasons why Maritime Partners settled on methanol. Methanol is available in over 100 ports globally. And our major routes, which are in the inland waterways, the Mississippi River, the Ohio River, the Missouri River, and then the intracoastal waterway that runs from Brownsville, Texas to almost Tampa, Florida. Is a tremendous amount of industrial complex along those waterways. And within about a 5-hour drive over the road, there are at least 3 major methanol production facilities. So in terms of access to methanol, that's the actual availability is within the range of the vessel. Furthermore, methanol is currently transported on the inland waterways in 30,000 and 10,000 barrel tank barges, and it is transferred to ships. It's also carried out as cargo in the offshore oil and gas space. Service vessels will take out methanol to the platforms, transfer the methanol off the vessel onto the platform. It's used for downhole drilling. If you add methanol to water, it reduces the freezing temperature. So when it goes down, it doesn't freeze. That's my limited understanding of oil and gas. But my point is that it's readily available, and it is very common in terms of the handling of the commodity.
You mentioned a few times this methanol to hydrogen conversion, right? And so then after the hydrogen is used in a fuel cell, is that right?
Correct.
So can you maybe talk about that whole fuel cell system, right? How does the methanol to hydrogen process work, and what are the advantages using it in that kind of energy generation?
I thought you'd never ask.
Yeah.
So the way the Hydrogen One is set up is it carries about 30,000 usable gallons of methanol. We also have deionized water on board. You mix 2/3 of the methanol with 1/3 of the deionized water. It goes into the hydrogen generator. It is basically a steam reformation process. So you heat it up, you're able to create a syngas. The hydrogen is extracted from the syngas. It's passed through a purifier. It flows into buffer tanks, low pressure. And then those buffer tanks feed the fuel cells. Fuel cells create power. Power sent to batteries for energy storage or sent to electric motors to power the vessel. One of the unique things about the Hydrogen One, in the production of energy from the fuel cells, we also make water. That water, we have a system that's going to capture, condense, and recirculate the water back through the ionized water holding tank and then reused again. We'll actually make more water than we can use on the vessel. And why that's important is that we've now shrunk the size of the water tank that we need to have. So we basically add water the first time, prime the pump, and never have to add water again.
Right. So then just to be clear for the audience, so we're talking about a electrically driven vessel here, right? So we're not combusting methane or combusting anything. It's combustion free. And we're talking about an electric run system. So I think that's super important. I know we've seen some pure battery operated vehicles, right? I don't know about anything on the water, but there's all the limits around batteries and everybody's talking about those issues. But here, right, you're able to use the fuel to generate the electricity on board, and the batteries, I guess, are just kind of your energy buffer tanks, if you will, right?
That's fair. Yeah, we do use them, but they're to augment power, but also really to balance the plant so that we can send power to it and then discharge it as we ramp up our.
Right.
We'll have 10 reformers and 10 fuel cells.
Okay.
So we have to bring them on and offline as power demand requires it, and to make up that difference, we tap the battery while we get the units going.
Okay, just maybe one point of clarification. You were talking about syngas just there. Can you define what is syngas?
So with regard to the system, and sure, Vic, in general terms, it basically, the methanol water mix gets heated to a temperature about 400 degrees C and creates a mixture of gas, which is made up primarily of like hydrogen and carbon monoxide and a couple of other different gases. And then from there, the hydrogen is extracted from that gaseous stream. And actually, that gas is then sent back through the system and combusted.
Super interesting. So we talk about efficiency. How does the performance of Hydrogen One stack up in terms of power output, range, and so on?
So some of the advantages that we have regarding the fuel cell system and the reformer system is that we are able to carry more hydrogen in the form of methanol and water than in the same volumetric space. So if you think of a cube, I can put one unit of compressed hydrogen in that cube. So 1 cubic meter, I can put 1 cubic meter of compressed hydrogen, 300 bar. I can put 9 times as much hydrogen in the form of methanol in that same 1 cubic meter, which for us is very important. And this gets to a broader discussion we're having around hydrogen as a propulsion fuel in the marine industry. Is that hydrogen is great. I love hydrogen, whether I want to combust it in an internal combustion engine or I want to run it through a fuel cell. But to carry it is a huge challenge. Before I joined Maritime Partners, we built the first liquefied natural gas bunker barge ever in North America. And I have very real experience in the challenges around compressed and cryogenic gases with respect to U.S. Coast Guard as your regulator. It is not easy. And by having methanol to water, I don't have to face a lot of those challenges.
Yeah, and I think you touched on it a little bit there, right? One of the big concerns that you hear out there when it comes to hydrogen is safety. So can you talk about what measures you've been taking to ensure safety and reliability of the methanol to hydrogen fuel cell system on Hydrogen One?
Yes, absolutely. Before I do that, you had mentioned the range and the power output. Let me touch on that, and then I'll get to safety. So the hydrogen generator has an 83% efficiency rating. A fuel cell has anywhere between 50 to 55% efficiency. We combine those two to match a diesel engine. We have a higher efficiency rating than the traditional diesel engine. So the system's already a little bit more efficient. With regard to the vessel itself, I mentioned the 10 reformers and 10 fuel cells and about 1.5 megawatts of battery. That'll get us 1,400 horsepower based on the fuel storage we have for about almost 6 days. So that'll be our range. And remember, that's at 100% output, which most vessels don't operate at 100% output all the time. And that's where it mimics a 2,000 horsepower inland push boat. And that's going to be like, think of Houston to along the intercoastal waterway to like New Orleans or Baton Rouge. That's kind of the range that this vessel will move. So, and then with respect to the safety, there are several safety features about this vessel that we are very happy with because of the challenges around the alternative, which would be a compressed gas or a cryogenic liquid. Is the methanol is stable at atmospheric pressure and ambient temperature. I don't have to do any kind of conditioning with the liquid fuel, not unlike diesel or gasoline. Two, when the pure hydrogen comes out of the methanol to hydrogen generator, it's at 0 to 2 bar pressure.
Wow, okay.
So it's very low pressure. That goes into the buffer tanks. And then 3, I'm producing hydrogen on demand. So if I shut everything down, we have a system that evacuates the buffer tanks. That's it. I don't have hydrogen on board. I have methanol on board, but I don't have hydrogen, and I don't have hydrogen at 300 bar, 400 bar, 500 bar pressure, which the Coast Guard is very, very happy with. Then we have energy storage. So if I have a problem with my system, right, I have 1.1 megawatts of battery that I can use to run the motors to push the vessel to the side of the bank. We also, because we have 10 units, basically 10 power units, if I lose 2, I have the ability to move power across the motors. That's another added benefit of safety in terms of operational safety.
Yeah, again, super interesting. So we're seeing a large number of the ports adopting emission reduction and noise reduction requirements for all the different vessels. How is Hydrogen One situated there? How does it contribute to reducing emissions compared to traditional push boats and diesel engines?
So the Hydrogen One, compared to the comparable 2,000 horsepower inland push boat, diesel mechanically driven in, but that's a tier 3 boat, will achieve a 99% reduction in regulated EPA regulated emissions running gray methanol. And that is because of the efficiency of the fuel cell and the reformers and the fact that I don't have internal combustion. Right. I create no NOx, no SOx, no particulate matter because I'm not burning diesel. I have minimal amount of hydrocarbons. I mean, we're talking like it's in the ppm range. And then the only thing that we do have is because we have methanol, we produce CO2. We do not produce any of the other greenhouse gases on the spectrum. We do produce CO2, but even producing CO2 with gray methanol, depending on the efficiency of the fuel cell versus the diesel engine, I could achieve up to a 38% reduction in CO2 emissions over a tier 3 diesel engine. Then if I add 2 gallons out of every 10 gallons of green methanol, we can achieve IMO 2030 targets. And then adding 4 to 4.5 gallons of green methanol out of every 10, we can achieve the IMO 2050 targets. So that means I still have a lot of headroom if I can source 100% green or blue methanol. Again, this all gets back to the fact we don't have internal combustion on board the vessel,
right,
for propulsion.
And I guess that also impacts the noise.
Oh, well, again, there's no reciprocate. There are no moving parts. Right. On the reformer. There are no moving parts. I mean, there are blowers on the reformer. There are no moving parts on the fuel cell. So noise it's not a reciprocating piece of equipment.
Right. Mm-hmm. Right.
Yeah.
We touched on a little bit earlier when we talk about the infrastructure and right now lack of infrastructure around hydrogen. So what kind of adoptions do you think need to be made at the bunkering facilities to accommodate methanol as a fuel? You said there were some manufacturing sites up and down like the ICC and so on, but what about at the facilities themselves?
So because methanol is already currently available, currently being transported on the inland waterways, matter of fact, I've talked to several of our customers that use our barges in their fleet, and they're like, look, it is a minimal amount of changes to the barge to be able to put hose handling cranes, to be able to pick up the hose and bring it over and set it on the boat and then hook it up. And because it's liquid at ambient pressure and atmospheric temperature, other way around, that it's easy to handle.
Okay, so some changes, but
minimal changes. And matter of fact,
right.
for the Hydrogen One, because of the amount of methanol that we will need,
Right.
we'll probably use tank trucks
Okay.
at either end of the route and just deliver methanol via tank truck
Right.
to start.
Right. For the one. Sure.
Exactly.
Yeah. So now for the big question. I mean, I'm sure everybody listening thinking, hey, sounds great, sounds green, but what about the costs, right? Everybody's always worried on the cost side, because if we have a great solution, but nobody can afford it, right, then that's kind of a maybe a roadblock there.
Right.
So when you're looking at adopting the energy efficient, low carbon technologies, right, we still need to make sure we have a good return on investment.
Correct.
So can you maybe talk about the economics here and what kind of considerations and cost savings we could see associated with using methanol as a fuel?
So it will be more expensive, but in my appreciation, anything beyond diesel, anything beyond internal combustion with diesel is going to be more expensive. So then the question becomes, how much more expensive is it going to be? The good thing about this methanol to hydrogen solution is that methanol is already available. I can get it in gray. I can run gray and be better than anything that diesel is. As soon as the color starts to change to blue or green, I can be better, but I have the ability to wait until not only is it available, but it makes more economic sense for me to switch the fuel. I can also do drop-in fuel. I don't have to have 100% gray or 100% green. I can add a little bit of green every time I buy gray. I can see a marked reduction in my emissions, but I'm not going to see, a huge increase in my overall fuel costs. With all technologies, the price of the technology comes down over time. I mean, the fuel cells today are going to be more expensive than the fuel cells tomorrow. The same thing with battery technology. And we feel that the reformer technology is going to be the same, right? Every iteration is going to get better. It's going to be more efficient, and it's going to be cheaper to manufacture. So that being said, people ask me this all the time: how much is it going to cost? And we believe that we can get it down over time to be within 20% of what it's going to cost to build a equivalent Tier 4 diesel towboat. So Tier 4 requires selected catalytic reduction after treatment system, and it's a little bit of a different type of engine. So we feel like over time we can get to within striking distance of what the alternative compliant diesel solution would be.
Within 20%, for sure, something I think that can be adopted. Nice.
Right. And again, Vic, that depends, man. If we see what's happening in Europe and we end up with a carbon tax,
right,
that's a whole different ballgame.
Yeah, absolutely.
Right.
Mm-hmm. Yeah. Good point. So for the vessel itself, has Hydrogen One undergone any testing, trials, or anything to validate the performance and the efficiency? And can you share maybe some of those numbers?
So the components have undergone, like the reformer, we had a string test. We were able to validate the ramp up time and the production. Within 6 minutes, we were able to reach 80% of the production rate on the reformer, which is where we thought we would be, but we actually were able to run it and pair it with a fuel cell. The vessel itself, we don't have any data yet because it's not complete, right? It's not in the water. We are jonesing to get it in the water so that we can validate and understand. Because honestly, I believe that our numbers are very conservative. I gave you that 5.8 day range. I want to know if we run it on a typical towboat operating profile, is it 7 or is it 10, right? But we won't know until we run the vessel. I want to see what the actual fuel consumption looks like. Everything we have right now is, I'm not going to say academic, but it's calculated.
Right. Okay.
So
well, it sounds like we have to have you back for another podcast then.
Oh, absolutely.
Great. Well, we look forward to seeing those, hearing all the good results.
Yeah.
So in your opinion, this is the first of its kind here with Hydrogen One. What kind of role do you see going forward for methanol and hydrogen fuel cell technologies in the maritime industry, right? Particularly as we start looking at all these decarbonization efforts going underway here in North America.
There's this dynamic around the size of a ship and fuel consumption, right? The less fuel you consume, the better your emissions profile looks like right now in current state. The savings that you get for going to a more efficient system look better on a ship that consumes more fuel. That's how you cover the cost of the fuel storage, right? I mean, I have a boat that's 2,000 horsepower. If I put cryogenic tanks on it, the vessel doesn't burn enough fuel for me to be able to recover the cost of that on a return on investment over a certain period of time. So, but where we run into challenges on the big vessels are the fuel cell technology. It's not scaled yet. I can't produce enough power without having like some crazy Frankensteinian system. You'll see methanol now on big ships. There are several vessels that are under construction that are going to run big 2-stroke methanol fueled internal combustion engines. Where this technology will come in and say, this is how you can put methanol through a fuel cell and try to eliminate your auxiliary generators. So you take the methanol, you convert it into hydrogen, you push it through a fuel cell. So I think what you're going to see is you're going to see more of this hydrogen to fuel cell technology is going to be to replace auxiliary power generation and not main propulsion on your bigger vessels. So you're still going to have the challenge of how you store the hydrogen. Do you store it in the form of ammonia and crack the ammonia on board and then feed the hydrogen through a fuel cell? Do you store it as compressed hydrogen or liquefied hydrogen, which, by the way, liquefied hydrogen liquefies at like 4 degrees above absolute zero, which that whole energy requirement's a different discussion for another podcast. So to me, the biggest challenge from the marine perspective is how to store the fuel that is not liquid at ambient temperature and atmospheric pressure.
Right. Trade-off of weight to range to power to all getting all those trade-offs optimized, right?
Right.
Mm-hmm. Okay. So from my side, that was all the questions I had. I don't know, Beau, is there any last comments you want to make about a company, about Hydrogen One going forward?
No, I mean, we're excited about it. It is, I will tell the audience, like, it is a regulatory slog, not because the regulators are bad, but because it is unknown. And our project right now is basically, it is tracking the regulatory review process right now. We are where we are, and we won't get to where we need to be until that is completely finished. And it is a challenge. So something new. What do? Confined space, people on board. Everybody has to be comfortable before we move forward. So, but we're working it every day.
Right. And that's the joys of being first to market. You get to
Exactly.
you get to learn everything step by step. So
Exactly.
So that's it for this episode of EnVisioneering Exchange. I'd like to thank my guest, Beau Berthelot of Maritime Partners, for joining us.
Vic, I really appreciate the time, and I thank Danfoss and the EnVisioneering Group for hosting us. Thank you.
Fantastic. Thanks. So don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever you listen to podcasts. Lastly, if you enjoyed this episode, don't forget to rate, review, and share it with your network. Thanks for listening, and talk to you next time.
This podcast is for information purposes only. The views, information, or opinions expressed during the EnVisioneering Exchange podcast series are solely those of the individuals involved and not necessarily represent those of Danfoss LLC and its employees. Danfoss LLC is not responsible and does not verify for accuracy any of the information contained in the podcast series available for listening on this site. This podcast series does not constitute professional advice or services. This podcast, including Danfoss LLC and the producers, disclaim responsibility from any possible adverse effects of information contained herein. Opinions of guests are their own, and Danfoss LLC in this podcast does not endorse or accept responsibility of statements made by guests. This podcast does not make any representations or warranties about the guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to herein. This podcast is available for private, non-commercial use only. You may not edit, modify, or redistribute this podcast. The developers of the EnVisioneering Exchange podcast site assume no liability for any activities in connection with this podcast or for use of this podcast in connection with any other website, computer, or playing device.